Colby, math.com.
On tonight's assignment, we're finding the greatest common factor and least common multiple of sets of numbers by first decomposing the numbers into their prime factorization and then sorting the prime factors into a Venn diagram. So let's do that for the numbers on problem 5. 18 is 2 multiplied by 9, and 9 is 3 multiplied by 3. When I'm finding the prime decomposition, I like to start with the smallest prime factor I can and then work in ascending order, but it's not required. You could come up with any two factors of 18. And the fundamental theorem of arithmetic tells us that we still get the same prime factors in the end. Every time you identify a prime factor, you should circle it though. 42 is 2 multiplied by 21, circling 2 because it's prime. 21 is not divisible by 2, but it is divisible by 3. It's 3 multiplied by 7. Both of those are prime, so I'm circling them both. 54 is divisible by 2. It's 2 27s. And 27 is 3 9s. And 9 is 3 3s. Once you've found the prime factorization of each of the numbers, then you can set up your Venn diagram. Draw the 3 circles. Make sure you draw them in such a way that you have sufficiently large intersecting pieces in case you might need to sort quite a few numbers into those intersections. And then label the circles. This will be the circle for 18. This will be the circle for 42. And this bottom circle is for 54. During the pause, why don't you try to do what we've been doing in class now and sort these prime factors into the correct locations on the Venn diagram. And then after you've done that, check each circle to make sure it really is 18, 42, and 54. And then find the GCF and LCM like we practiced in class. Come back after the pause and see how you did.
Paused.
The first thing you want to do is deal with this intersection of all 3 numbers. And so I see whether I have any prime factors that are common for all 3 numbers. And I do, because each of these numbers has 2 as a prime factor. So I cross 1, 2 off of each tree, and I place it in this intersection. Now, the reason I'm able to cross off 3 2s is I've just placed 3 2s, even though I've only placed 1 2, because it's in each one of these 3 circles, it counts as 3 2s. There's also a 3 that's common to all 3 numbers, and so I'll place that prime factor 3 also in the intersection of all 3. Now when I'm comparing what's left, I've got a 3 here, a 7 here, and 2 3s here. There's nothing that's common to all 3, and so I'm done with this intersection of all 3. But there is a 3 on the 18 and the 54, so I'm going to cross 1 3 off of 18 and 1 3 off of 54, and I placed it here in the intersection for 18 and 54. This 7 belongs only to 42, so I'll cross it off and place it in the 42 only section. And this 3, the only remaining 3, will go in the 54 only section. It's really important once you've done this to check your circles. So we talked in class about how you can hold up your hand and block out 2 of the 3 circles and check 1 circle at a time with this curved part of your palm. If I just focus on the 18 circle, I have 3 times 3 times 2, which is 9 times 2, which is 18. If I focus just on the 42, I have 3 times 2, which is 6, times 7 is 42. And then for the 54, I have 3 times 3 is 9, 3 times 2 is 6, and 9 times 6 is 54. So I feel confident that my Venn diagram is set up correctly. The GCF, the greatest common factor, is the product of the prime factors in the intersection of the Venn diagram. So 2 multiplied by 3, which is 6. And if we took the time, we won't, but if we took the time to do UT diagrams and identify all factors of all 3 of these numbers, 6 would be the largest factor that you would see shared by all 3. It's much easier to get that using the Venn diagram, because the Venn diagram not only lets us identify the GCF easily, but also the LCM. Let's just talk about multiples in general for a second. If you look at this 6, the GCF, 3 sixes is 18. So 18 is a multiple of 6. It's 3 sixes. 7 sixes is 42. So 42 is also a multiple of 6. And 9 sixes is 54. And so you see that all of these numbers are multiples of 6, and 6 is the greatest factor for which they're all multiples. And so that's the idea behind multiples. Also, if I look at the whole 18 circle, 3 18s is 54. And so you start to see some multiples outside of the circles also. But if we want the least common multiple of all three numbers, we can find that just by finding the product of all of the prime factors. It's called the union. All of the prime factors in the union of the Venn diagram. So if I multiplied them all together, but there's a shortcut for that too, because I already know that all of these prime factors multiplied together are 54. And so I just need to multiply 54 times 7. 54 times 7 is 350 and 28, so 378. We could have also multiplied 42 times 9. That would also give you 378, or 18 multiplied by 21. As long as you multiply all the prime factors in the Venn diagram together, you'll get the same least common multiple, which is 378. Okay, I hope that helped. I'll see you tomorrow.